The first thing you should find in these is the horizontal asymptote. Right? It is much easier to find the horizontal asymptote before you start factoring, and that's what I've done here. So go ahead and find the horizontal asymptote. Remember, the horizontal asymptote can be found by comparing the degree of the numerator, and the degree of the numerator comes from the highest exponent and the degree of the denominator. If the numerator has a higher degree than the denominator, then there is no horizontal asymptote. After you've found the horizontal asymptote, go ahead and factor everything out. So there's a common factor of x, which I took out, and a common factor of 4. Then once I've factored out the common factor, I factored the regular trinomial, right? That's the quadratic form. Well, this is quadratic. Now what you want to do is get rid of common factors. But don't like scribble it out where you can't see what it is, all right? Because you're going to need that in a second. Because this common factor here that reduces, this is where the whole occurs. The whole occurs where the common factor can be made equal to 0, right? So 3 minus 3 is 0. So the whole in this graph occurs at x equals 3. It is the reducible factor that produces the wholes, okay? All right, now we're going to look for the vertical asymptote. The vertical asymptote, you look at the wholeless version. Get rid of the factor that is in common. I think I'm running out of space over here, so I'm going to write it over here. So it's x times x plus 1 over 4 times x minus 1, right? Now, these two do not reduce because they have different signs, okay? And it's not all different, okay? The ones are different, but the x's are not, so it's not considered opposite. All right, anyways. So the vertical asymptote is going to come from the denominator of x equals 1, and there's zeros, or someone said, why do you call them zeros? Okay, fine. X-intercept. X-intercept is at x equals -1 and 0. The two factors, what makes them 0, right? X is a factor, so 0 makes x equal to 0. X plus 1 is a factor, -1 makes x plus 1 equal to 0. All right, so now I'm going to plot the x-intercepts and the vertical asymptote. Wow, these are really close together. Okay, now what do? We're going to make a sign chart using the x-intercepts and a vertical asymptote. So we got one at -1, 0, and 1. And here's the trick. Okay, at the far left, all the factors, unless there's a minus sign in the x, and notice none of these x's have a negative sign on them. Okay, as long as that doesn't happen, you just count how many factors you have, and that's how many negatives you're going to have. So there's 3 factors, so it's going to be negative, right? Because if you plug a number out way over there, all of these factors are going to turn negative, unless there's a negative sign in front of the x. All right, so that's negative. And then remember, as long as there's nothing weird going on, it's going to alternate. So negative plus, negative plus. All right, now behavior around intercepts and vertical asymptotes are a little different. Okay, so we're starting on the left-hand side, so it's left of -1. It has to hit that 0. It has to hit that x-intercept. And it says negative, so that means it's below the x-axis. It's below the x-axis. Okay, if it's negative, it's below the x-axis. If it's positive, it's above the x-axis. And notice what happens. It's going to get back to 0. It's going to get back to 0. So you don't have to go very high. Just go just a little bump up. Okay, and then it says negative. It goes negative afterwards. All right, now we're approaching a asymptote. We're approaching a vertical asymptote. Whenever we have a vertical asymptote, if you watch the vertical asymptote video, it's going to go way down there or way up there. Now, it's negative between 0 and 1, so it's got to shoot way down. If it's negative, since it's negative, it's got to be at the negative end of this vertical asymptote. So this is going to go all the way down like that. Okay. Then you might be wondering what's happening on this side. I'll get back to that in a second. Let's go back to this one. So on the vertical asymptote at x equals 1, it's positive on the other side. Now, some students like to connect these, but they don't connect. Okay, they don't connect. Vertical asymptotes are not continuous at the vertical asymptotes. So don't expect it to be over on this side. It's positive. I mean, it is on this side, but it's way up here. It's positive. So that means, and with the vertical asymptote, it's got to be way up or way down. And it's positive, so it's going to be way up. Okay, now this is where it gets weird. Remember, there was no horizontal asymptote. So that means it can't do this. If you draw it like that, that suggests a horizontal asymptote. But it can't do this either. It can't go straight down because it never turns negative. So what happens is it goes down and then goes back up. Yeah, I know, confusing. But that suggests there's no horizontal asymptote because it's going up, okay? And it doesn't go negative, so it doesn't cross back down. On this side, there's no horizontal asymptote, right? There's no horizontal asymptote on either side, okay? And to the left of -1, it stays negative. It doesn't become positive. It's not going to come back up. So go ahead and just draw it down, okay? Someone asked earlier about a possible diagonal asymptote. Well, that's what that's approaching right there, a diagonal asymptote. Alright, so how do we graph the hole? There is a hole at x equals 3. So there's 3, and just put a hole at x equals 3. And that's it. Right? Just put a little circle there, and that will let me know that you know that there's a hole there. Okay. By the way, what's a hole? Technically, it's whatever makes the original function undefined, right? If it makes this factor equal to 0, so that means you got 0 over 0, and that is undefined. So that's why there's a little gap in your function, in your graph, right? That's our little hole. That's it.